All right, are you guys ready to oxidize some alcohols? So you see that I have set up in here already my round bottom flask at 50 milliliter, which is a little bit bigger than we need, but that's all I could find. I have my little magnetic stir bar in here. It is clamped into our iron rod above our stir plate. First thing I'm gonna add is 1 gram of borneol. Carefully. And then 4 milliliters of ethyl acetate. Then I'm just going to start stirring it on stir setting number 2 until it all dissolves. So if you zoom in, you can see that all the borneol is dissolved. It's all liquid now. So now I'm going to add 2.4 grams of oxo and 0.08 grams of NaCl. Alright guys, it has been exactly 7.5 minutes, so I come here to bring you some stirring coverage of our round bottom flask. If we go in here and take a little look at it, really not much has changed. A little bit clear, slightly yellowish in color, and it doesn't seem, well, it seems to be warming up just a tiny bit. Back soon. Alright, so we've had our solution stirring for 15 minutes, and if John zooms in here, we can see that we have a solid down here at the bottom, and then we have our liquid up here at the top, and that little white chunk, that big one in there, is actually just a stir bar, so don't worry about that. So now what we're going to do is add 15 milliliters of deionized water. Continue stirring it slowly. And then just enough sodium bisulfate to get rid of the excess oxidant. We're going to check for the excess oxidant using potassium iodide starch test paper. So if we see a little blue dot on there, that means there's oxidant remaining and we have to destroy it and add a little bit more sodium bisulfite. And if it's clear and there's no change on the paper, then we're good to go. Alright, here we go, adding a little bit of sodium bisulfite. And we're going to stir it a tiny bit more. Okay, I'm going to turn it off. I'm then going to check the aqueous layer, which is the layer, you can see the organic up here, kind of cloudy at the top. Sorry, our audio sucks. I'm going to dab in here. And then just put a little bit on our starch iodide paper. And you can see it turned brown, so that means we have to add a little bit more sodium bisulfite. Stir it again. So I added 2 more little scoops of sodium bisulfite. And the final test I made is this top part right here. You can see it's totally white. It doesn't look brown or burned or anything like that. So we're good to go. Okay, so we have our product all finished. I've added the deionized water. We've gotten rid of all the oxidant. We tested it on the iodine starch paper and it looks good to go. So I'm going to remove my product now, make sure my stopcock is closed, and then add it to my separatory funnel. I'm going to take 2 milliliters of ethyl acetate, add it to my round bottom, and just swirl it around a little bit. And pour it in. Swirl it and vent it. There we go. Now I'm going to let it sit until the layers separate. So our aqueous layer is going to come out on the bottom. Pull it out first. And then I'm going to drain the organic layer out from the bottom as well. Alrighty, here we go. Actually going to lower this a little bit. Oh, creating a vacuum. There we go. Okay, so there's our first aqueous layer. I'm going to pull out the rest of the organic that was on the top. Alright, so we got a little bit of leakage, so source of error, that's okay. And now I'm just going to re-extract the aqueous layer 2 more times with 15 milliliters of ethyl acetate each time. So I finally finished washing all the aqueous layers with a little bit of ethyl acetate to remove all the organics and pull them into the organic layers. So aqueous layers, I'm now going to set aside. Now I'm going to take all of my organic layers and wash those 3 times with a solution of brine. Alright, so I finished washing the aqueous layers with 3 5-milliliter portions of saturated NaCl or brine. And here are 3 layers, ta-da, looking like this. So we're going to add a little bit of the anhydrous sodium sulfate, our drying agent, to absorb any extra water that might be sitting in our ethyl acetate. So there it is. We're going to swirl it around, and then we're going to hold it up and see if we see any droplets of water sitting in there, and we look good. So now I'm going to decant it into our round bottom flask, which weighs 38.029 grams when empty. Alright, I'm going to take my round bottom now over to the rotary evaporator. Alright, here we are at the rotary evaporator. I have my product here clipped in. I'm now going to lower it into the water bath. Start it spinning slowly, turn on the vacuum, and then close the system. Alright, so we've been here at the rotary evaporator for just about 2 minutes, and as you can see, our product is already solidified. We have all of the solvent removed.
See ya.
So we're going to pull it off and then go to the next step. Alright, so we have our Rotovap solid here. This is our crude material. I have just tared my scale, and we're going to see how much we've collected. So now our round bottom with our crude product weighs 38.743 grams. Okay, so now we're going to go back to the hood, where the sashes were definitely down when we were over there. Put on my glove, and add a tiny bit of dichloromethane to our round bottom flask. Alright, as you can see, our solid is kind of gunky and swirly in there, so if we add a little bit of DCM, we'll be able to dissolve it and then transfer it to our beaker. Alright. Like this. I'm going to add a little bit more DCM just to get those last few little chunks. And there we go. So now our crude product is in our beaker. We're going to sit on top of here, put a watch glass, and ice on top. So first, the DCM that we used to transfer it into the beaker is going to evaporate off and leave the beaker, and then our product is going to sublime all the way up here and crystallize on the top, so we will get pure product crystals forming on our watch glass and maybe even the top of our beaker.
So just as a quick update, our DCM is evaporating off and the recrystallization method is working. You can see that it's condensing at the top because of the ice bath. So we will keep you posted once all of the DCM is gone and our purified product is recrystallized.
Boil, trouble and toil. As you can see, we already have some of our products sublimating. That's its fog up here, and it will eventually crystallize up there underneath the ice. Magic. Alright, so we've let our product sublime for about 10 minutes now, and you can see the white crystals from about the 50 milliliter mark on our beaker all the way up to the top here. And then that dark line around the bottom and those little dark spots on the bottom of the beaker, those could either be degraded product or impurities that we're not able to sublime away. Okay? So the next step is going to be, I'm going to take an NMR spectra, I'll send you guys that data later, an IR spectra and a melting point. I will tell you what the onset and meniscus points are so you guys can analyze the data from the comfort and safety of your own homes.